So now let's take a look at the second and higher derivatives. So far we've learned what is a first derivative, right? So we use f prime x to denote that. And f prime x is just a partial y over partial x. So that means that we take the derivative of the function f for only once. So that's why we use 1 prime to denote that, right? F prime x. So second derivative means that we take the derivative of the first derivative. Or let's say we take the derivative of function f twice. And we can use f2 prime x to denote the second derivative. Right here we have 2 primes, means we take the derivative of function f twice. So f2 primes x means fx is differentiated with respect to x twice, or f prime x is differentiated with respect to x once. Right, it's the derivative of the first derivative. So we know that the first derivative is also a function, right? So fx is a function, so f prime x, you take the first derivative, is still a function. And so f2 primes x is also a function, right? So any of the derivatives are functions. And we can use another notation but the same meaning to denote the second derivatives, right? So they are the same. So this is d squared y over dx squared. So this is because dy over dx is the first derivative, right? And we take the derivative of the first derivative for one more time. Right? So it's d, the first derivative, over dx again, right? So we know that there are 2d on the numerator, so that's why it's d squared and then y. And then in the denominator, is dx. There are 2 dx, so that's dx squared. Right? That's how we use this notation, how we find this notation. So if you take the derivative for another time, right, for the second derivative, then we have the third derivative. And we can use f3 primes to denote that. So f3 primes x means we take the derivative of function f for 3 times. And also we have f4x, the 4 is in parentheses, right? Because it's getting really complicated if you write a lot of primes here, right? So we just use number to denote the order of derivatives. So f4x means we take the derivative of the function f 4 times, right? And so on. And we can use d cubed y over dx cubed to denote the third order derivatives. And then f4x is the same as d to the 4 y over dx to the 4, right? So here, so we have different notations. But all you need to know is that for now is that the f2 primes x is the derivative of the first derivative, or we take the derivative twice, right? And all of them from fx to f4x or fnx, right? Fnx, that means we take the derivative for n times. All of them are functions. All of them are functions. So let's see an example. Find the first through the fifth derivatives of the function. So here's the function. So the first derivative, f prime x, as we know that there's the equation, right, the formula you can use. So that's 16, which is 4 times 4, and then times x cubed, minus, we plug the 3 in front of the x and get 3 times x squared, right? So here this is 3 minus 1, right? X squared. And then plus 34x, and then plus 3. And then we can get rid of this constant term, right? When we take the derivative. So that's our first derivative. And for the second derivative, that's f2 prime x, we take the derivative of the f prime x. Right, so that is to take the derivative of this function. So that's 48 times x squared minus 6x, and then plus 34. And then again, we get rid of this constant term. And so on, we have the f3 primes x, the third order. It should be 96x minus 6. Again, get rid of this constant term. And then f4x is 96. So f5x, or the fifth derivative, is just a 0, right? Because f4x is a constant term. And if we take the derivative of a constant term, we get 0, right? Because the rate of change is just a 0. So from here, we can see that when you take the derivative, you actually downgrade or decrease the highest order of the function, right? So for example, the original function, the highest order of x of the original function is 4, right? And then if you take the prime, the highest order of x becomes 3, right? And then it becomes 2, and then 1, and then the constant term, right? So a function, if it's not, so for this kind of function, we said that, okay, we can calculate the fourth order of derivatives. But from the fifth order, it will just be 0, right? It will take the fnx, it will still be 0 if n is larger than 5. So that means that if we take one of the order, and then we change or decrease the order once, and then decrease another once, okay. So how do we interpret the second derivative? Right, so here we just focus on the second derivative, right, because that's more useful when determining the maximum and the minimum. So for the first derivative, we know that f prime x is the rate of change of function f. And also f prime x means the slope of the tangent line, if you can remember. So back here, so here, from two graphs, there's a conclusion that the slope of the tangent line at any point x0 is equal to the derivative at the same point. So here we mean the first derivative, okay? So the first derivative of the function is just the slope of the tangent line at the point. Okay, so fx is just a slope. And then f2 primes x, it means the rate of change of f prime, right? So f prime x is the rate of change of function f, so f2 primes x is the rate of change of function f prime, right? Because for function f, we take the first derivative, we get f prime x. And for f prime, we take the first derivative, and then we can get f2 primes x, right? So what does that mean, the rate of change of function f prime? So you can think of f prime as the slope of the function, right? So the second order, a second derivative, means the rate of change of the slope, right? The rate of change of the slope of the tangent line. So here are some of the cases. So if f1 prime, right, the first derivative, is larger than 0, so that means that the slope is positive, right? The slope is positive. it means that a function is increasing, right? Because the slope is positive, right? The slope is positive. If the slope is positive for all the points of the function, that means that it's an increasing function. And if the first derivative is less than 0, so that means that the function tends to decrease, right? For all the slopes, if it's less than 0, it's like downward sloping here. So that means that the function is decreasing, right? So we can use the sign of the slope to indicate or to find out if the function is increasing or decreasing, right? And so for the second derivative here, f2 prime x is larger than 0. So that means that the slope of the curve is increasing. The slope of the curve is increasing. So for example, if I draw a graph like this, again, so here the slope is like this, and then for here the slope becomes steeper, right? So because the slope is a positive number, so maybe here the slope is 1/4, just an example. So here the slope becomes 4, right? So a larger positive number. So if f2 primes x is larger than 0, that means that the slope of the curve is increasing, right? The slope of the curve is increasing from 1/4 to 4. So if we draw the line here, so at this point x0, the f2 primes x0 should be a positive number, right? Because the slope of the curve from the left side to the right side is increasing, right? It's becoming steeper. The tangent line is becoming steeper. So that's how we say that, okay, f2 prime x is larger than 0. And if f2 primes x is smaller than 0, that means that the slope of the curve tends to decrease, right? Just the inverse case of this one. Okay, so here we have 4 cases based on the different signs of the first and second derivative. So first case, if the first order, the first derivative is positive and the second order is also positive, so that means that the slope of the curve is positive and increasing, right? So for example, just this graph shows the example. f1 prime x is larger than 0. That means that there's an increasing function. And also, the change of the slope is also positive. That means that the slope of the curve tends to increase too, right? So that means that the tangent line, remember the tangent line is just the first derivative, right? It means that the tangent line becomes steeper and steeper around the point x, right? So that means that the slope of the curve is positive and is increasing, like this graph. So it also means that the value of the function is increasing at an increasing rate. So for the function, it's a curve here, right? It's a curve here. So the value of the function is increasing, right? It's an increasing function. And for any point here, if x1 is less than x2, so the slope of x1 is less than the slope of x2. So it means that at the point x2, the slope, the tangent line slope is larger than the slope of the tangent line x1. Where the function is increasing, and it will increase more as x gets larger and larger, right? So this is the meaning of the first case, when the first order and when the first and the second derivatives are both positive. Right. So for case 2, if the first order is positive, but the second order is negative, so that means that the slope is positive, right? Because the first order is positive, but at a decreasing rate. So we can draw a graph like this, right? The slope is positive, right? The slope is positive. You draw the tangent line. It's an upward sloping, but the slope, the magnitude, right, of the slope is decreasing. So here the slope may be 3, but for this point, the slope may be only 1/2, right? So if you draw the line, so if you pick up a point x0 here, for the left side of the x0 and the right side of the x0, the slope is decreasing, right? And it also means that the value of the function is increasing, but at a decreasing rate, right? As we can see from this graph, for this curve here, it's an increasing function, right? The value is always increasing as x becomes larger. But the value of the function is increasing at a decreasing rate, right? So from x1 to x0, the function, the y, or the value of the function increased by this much. But from x2 to x3 here, the value of the function only increased this much, right? It's much less than from x1 to x0. So the value of the function is increasing, but at a decreasing rate. So this is the second case. And for the third case, the first derivative is negative, and the second derivative is positive. So this case, it means that the slope is negative, right? Because we have a negative first derivative, and it's increasing. So let's draw a graph. Like this, right? The slope is negative, it's a downward sloping line, but the second order is increasing, but a second order is a positive number. So that means that the slope is actually increasing. So here, we need to pay attention that because this is a negative number, right? So all the numbers here, all the first derivatives here are negative. So increasing means it will increase from, for example, negative 10 to negative 5, right? So this is what we mean by saying increasing, right? The magnitude is becoming smaller, but because it's negative, right? It has a sign in front of the magnitude, right? So from negative 10 to negative 5, we say that the slope is increasing, right? Because negative 5 is larger than negative 10. So for here, the slope of the curve, for example, is negative 4. And for here, it's only negative 1/2, for example. So from negative 4 to negative 1/2, the slope is increasing, right? So the slope is becoming flatter and flatter. And so we said that it's increasing. Right? And so for this case, the value of the function is decreasing, right? It's a decreasing function, but at a decreasing rate, right? So from x1 to x2, the function decreased this much, and then for x3 and x4, the function only decreased a very little bit, right? So the function is always decreasing, but at a decreasing rate, right? And so for the last case, the first derivative is negative, and the second derivative is also negative. So here it means that the slope is negative and decreasing. Right, so here decreasing means because the slope is negative, right? So decreasing means it decreases from -10 to -15, for example. Right, the magnitude is becoming larger, but because it's negative, right? The -15 is smaller than -10. Right, so we said that the slope or the first derivative is decreasing. So here is something like this, right? The slope is always negative. So here the slope is downward sloping. Here the slope is also downward sloping. And the slope is becoming steeper and steeper. Right, so here the slope may be -1/4. So here the slope may be -4. Right, from -1/4 to -1/4 or to -4, the slope is decreasing. So the value of the function is decreasing. Again, it's a decreasing function. Right, the value of y is decreasing as x goes to as x becomes larger. Right. The value of the function is decreasing at an increasing rate. Right, it will decrease. At first, it decreases just a little bit as x goes to as x becomes larger, but then it will decrease the very at a much faster pace. Right. So we can draw these four graphs. We can summarize the four cases based on the four graphs here. Right. For the first graph here, from point A to point C along the curve, f2 prime x is always a negative number. Right, because here at point A, the slope is a positive, right, and a large positive number. But it will decrease until it reaches point B where the slope is 0. Right, it's a flat line. So the rate of change is 0. So slope is 0. So from A to B, the slope decreases from a large positive number to 0. Right? And then for the point C, the slope is a negative number. Right? So from point B to point C, the slope changes or decreases from 0 to a negative number. So it means that from point A to point C, the slope is always decreasing. So the second derivative is always negative. Right. So from A to B, or from x1 to x2, so the first derivative is a positive number, right? Because the function is always increasing, although it's at a slower pace, right? So this should be case 2. And then from B to C, f prime x is a negative number, right? The tangent line becomes downward sloping, so the function is decreasing. So this should be case 4. Okay, and then for the second graph, the second derivative is always a positive number, right? Because from point D to point E, the slope changes from a very negative number to almost 0. Right? So that means that the slope increases from a negative number to 0. And then from E to F, the slope of the function increases from 0 to a very large positive number. Right? So that means that from D to E to F, along this curve, the slope is becoming larger and larger. here we include the sign, right? Because at point D is negative, right? So it has a minus sign before that. So from D to E, we say the slope increases, right? So the slope of the curve increases from D to F all the time. So then we mean that the second order of the function is a positive number along this curve. And from D to E, the first order is a negative number, right? Because it's downward sloping all the time, and the function is decreasing from D to E. So this should be case 3, right? And then for E to F, the first derivative is positive. The function is increasing, right? Y becomes larger as x becomes larger too. So the first derivative is a positive number, so this should be case 1, right? So here it is 2 graphs. We conclude the 4 cases by drawing the graph, drawing the curves, right? And pick up the specific points and to show that, okay, what is it like if we have these 4 cases. Okay.